Good morning. This is the first video for stats section 5.3. We're going to talk about conditional probability. Let me remind you while I'm thinking of it that on Wednesday morning, we're doing our normal live lesson. We're actually in stats going to do a Kahoot. So we're going to have a little bit of fun, I suppose. Just kind of reviewing this topic and the topics before. So I think that should work fairly well. So that's Wednesday morning. Today's Tuesday, I think. So, all right. Real quick review of what you should know already about probability, and then we'll throw conditional probability. I don't think it's a brand new topic, but the formula might look different. All right, so let's clarify some things that you should know already. So, and I have two different examples, one with a two-way table, and then one with a Venn diagram, both asking the same kinds of questions. We should know this already. Let's make sure we know what we're doing here. So I've got 240 people, broken down either by male or female, or whether they prefer an SUV versus a sports car. And so if I pick one person randomly and I say, again, let's be guilty of the notation. If I say, what's the probability, this first one, the probability that they are a male? Well, that's just the total males out of the grand total. That would just be, let's see, total males is 60 out of 240. At the moment, I'm not at all worried about reducing fractions or making percentages. And the second one, the probability of the probability they prefer a sport utility vehicle, that's just 156 over 240, nothing to that. Now, I'm actually going to keep going down the right column. We'll do the last one on the left. Down here it says probably of M and C. You've got to know that means the overlap, the intersection. So M and C, male and sports car, that's just the 39 people out of the 240. Please don't tell me the probability of male and sports cars is just 39. The answer 39 for a probability makes no sense. 39 out of 240. Okay, now let's look at this fourth one. It says the probability of female or SUV. That's what that asks. So remember I gave you a formula last time on how to find the probability of A or B. And we can use it, or we can just kind of know what they're asking and figure it out. So I'm going to do this two different ways here. First, if I want F or U, when I see a two-way table, my first thought is, female, that's those two green numbers are the female numbers. And then U is sport utility. I think that number is there. I would argue that of my four actual numbers, including my totals, that those three numbers are either female or SUV. If I add those three numbers together, I get 130, 180. I think I get 201 out of 240. That's absolutely the right answer to that question. Now, the formula I gave you last time, I want to make sure you understand that would still get me there. And with a two-way table, it might be doing a little more work than necessary, but I could do it that way. So the formula said it would be the probability of the first one plus the probability of the second one, and then minus the probability of the overlap. And remember, the goal of subtracting the overlap was I don't want to not count it, I want to not double count it. So let me see if I can use this formula and get to the same spot. So the probability of F would be, 180 out of 240. And I will notice that that's that total right there. And then plus the probability of U, and that's, the 156? That's 156 out of 240, which would be that total. If I were to just add those numbers, you've got to recognize that this number right here got counted twice. If all I add is the row total and the column total. So that's why I have to subtract out the overlap, which is the 135 out of 240. Again, I'm not subtracting it to not count it. I'm subtracting it so I don't double count it. And if I add that, I get 336 minus 135 is in fact 201 over 240. So I don't want you to think one of those ways is better than the other. The formula will always work, but if you give me a two-way table and you ask for F or U, again, my first thought was to add up those three numbers because those are the female or the U numbers. So that's two-way table review. We kind of did that. It was probably review the first time. Similarly, I should be able to answer the same types of questions given a Venn diagram. So I've got a Venn diagram. These are college majors. I've got some people who are chemistry majors, Spanish majors, math majors, and then some have a couple of majors, some have all three majors. So, and then down here in red, we do need the grand total. So I added up all the numbers. So the total here, total here is 260. And don't lose that five. There must be five people or so far that have none of those three things as a major. All right. So now again, we need to be able to answer the same kinds of questions. So here's the first one. Most common mistake says the probability, if I randomly pick one person, what's the probability they are a math major? The answer is not 85 over 260. It is incredibly tempting to think that, but it's not. The math majors, all of these people are math majors. So we've got to, in fact, add up all of those numbers in there, 85 and 60 and 15 and 5, and that's 165, I believe. The probability of choosing a math major, 165 out of 260. So be real careful with the Venn diagram. That's the most common mistake people make with Venn diagrams, is they think that the probability of math is just that 85 out of the 260, and it's not. Okay, so next one is probably an S and C, Spanish and chemistry. Again, I would argue that area right there they're Spanish majors and they are chemistry majors. It's the intersection, the overlap of those two circles. What's that? 15 plus 3, that's 18 out of 260. That's that. And now let's go back to the same, not dilemma, but the same, what do I do about something or something? And again, I can either add up the right numbers or use the formula, probability of C or M. Again, the way I see this first is which numbers are anywhere either in the chemistry or the math circles. I see that number and 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 that number. I would argue that all of those things that I just highlighted in yellow, all those people are chemistry majors or they're math majors. They might be both, but that still qualifies. So if I just add up those yellow numbers, 20, 80, 100, 185. I get 185 out of 260. That is absolutely how you could and how I probably would do that one. But the formula for A or B does work. So the formula says, I'm trying to find this using the formula. Again, I'm hoping I'm going to get the same answer. It is the probability of, let me actually raise this up a little bit so it fits on this screen. This is the probability of C plus the probability of M. Oh my gosh, I'm struggling with the parentheses here. And then minus the overlap, probability of C and M. That's what the formula says. First probability plus the second probability minus the overlap so as not to double count it. So the probability of C is all those, which we said was what, 20, 80, 95. I think that's 95 maybe. Did I not do that? Oh, no, I did that. Okay. That is 60, 80, and 95. That's 95 over 260. Plus the probability of M, that's all of these I circled in purple there. That's 20, 80, 165 out of 260. Again, if I just add up those two, I want you to see that I would have double counted the overlap there in the middle when I don't want to double count it, which is why I have to subtract it. And I subtract the overlap, and the overlap is, what's that, 75 out of 260? And sure enough, if I do that, I get 260, 180, no, 260, 185 out of 260. So again, you get the same answer either way for this A or B. With the Venn diagram, what I did first, adding up those yellow numbers to get this answer is how I would do it. So there's your review of what you know so far. Now we're going to take the same two pictures, the two-way table and the Venn diagram, and we're going to introduce what conditional probability is and how to find it, and then there's just a simple formula. So we're back to the two-way table. Now, I wrote 3 questions down here. I need you to understand that all 3 of these, I'll go like this to make sure you see that there's 3 questions being asked here, are all asking exactly the same thing. The first sentence says, if a male is chosen, what's the probability that he prefers SUVs? The second says, what's the probability of preferring SUV given we choose a male? And then this third one is this new notation, the probability of SUV given male. This vertical line in a probability means given. What's the probability of SUV given male? So that means we already know we chose a male. If this first one might be the clearest, if a male is chosen, I would argue that in this particular problem, that row is the only row we're dealing with. If a male is chosen, what's the probability that he prefers SUVs? What you've got to know with conditional probability, the denominator changes. It is no longer the grand total of 240. We know we chose a male. There's only 60 males. Oh, no, I'm not sure I put the 60 there. There's only 60 males. Out of the 60, if we know we picked a male, what's the probability we picked an SUV preferrer? That would be what? 21 out of 60. So again, whenever you see a conditional probability, you've got to know that the denominator changes. And then what if I asked another? What if I said, what's the probability of female given sports car? Well, that means we know we picked a sports car person, which is this, only that column. Understand it could either be a row or a column. So out of the 84 sports car people, if we know we picked a sports car, what's the probability we picked a female? Well, that'll be what, 45 out of the 84. So again, whenever you see a probability question, remembering that in the first two slides, all of the probabilities had the grand total as the denominator. But as soon as you're asking for something given something else, the denominator changes to the grand total of whatever it is that we are given. So there's your couple examples of the two-way table. And now here is same thing with a Venn diagram. This says, if we know we've chosen a chemistry major, what's the probability he or she is also a Spanish major? So we know we have a chemistry major. So my grand total is no longer the grand total 260. My grand total is my chemistry major. Like if I know we chose the chemistry major, this says the this right here, probability of S given C is probability of Spanish given chemistry. Well, how many chemistry majors are there? I'm going to add up all the chemistry numbers. 60, 75, 95, I believe it was. Out of those 95, how many of them are Spanish majors? That's those two right there. 3 plus 15 was 18 out of 95. So you have to understand what you're being asked when it is asking a conditional probability. And then let's think about this. Let's turn this into a formula. So what do we do here? It was 18 over 95. 18 was I would argue 18 is the overlap between Spanish and chemistry. That is the probability of Spanish and chemistry. That's the overlap. And what one on the bottom? Just the chemistry, the probability of chemistry. So the terminology that I use, the probability of something given something else, it's the overlap on top over the second one, the probability of the second one. In this case, it was chemistry. And so to finish this up, here's the formula. And let me get this out of the way. And I wrote it twice because the direction matters here. It's the probability of A given B. The probability of A and B, or the probability of B. Notice that this here, that's got to be the second one. The overlap goes on top. Yeah, I can write the overlap. I can write in either direction. Probably of A and B and B and A. That doesn't matter. That overlap order doesn't matter. But for the conditional probability, notice these two formulas. One says the probability of A given B. The other says the probability of B given A. They both are the overlap on top, but on the bottom is the probability of the second one, the probability of the thing that you are given. So I don't think questions like that, if I go back to like this one, just if a male is chosen, you've probably seen probability questions like that before, but the formula you just need to get comfortable with. The probability of A given B is the probability of A and B over the probability of the second, which is B here. Okay, so I think that's all I've got for this, just the beginning of section 5.3, but it gets us enough for today's assignment and for tomorrow's live lesson. So here's the assignment, just what is that, 6 problems, and introducing it introduce some basic conditional probability problems. And again, live lesson tomorrow, during which we will be doing a Kahoot. So if you've got a phone, that works best. Otherwise, you can have your screen split and we have my screen on one half where I'll be showing you the questions, and then you can on the other half be choosing your answers. So I will see you all in the live lesson. Have a great Tuesday.